Hello, everybody. How are you? I hope that everybody is staying safe and your family is safe. As I mentioned in yesterday class and the first class, and that is mentioned in the course handout, that all classes will be recorded. I changed the setting of the class so all profile pictures will not be appear in the recording unless the student open his video, and this is his call or her call for the student if you want to be appear in the video. However, I make all student profile pictures to appear as blank or anonymous in the video for privacy issues. Due to the video file sizes, I created a YouTube channel. I will share it with you in a bit. This is my YouTube channel. So it has both videos. For example,
Sir,
this is the
we can't
this
see
is
your
the
screen.
first class.
We can see your screen at the moment.
Sorry?
We can't see your screen at the moment.
Now, can you see the screen?
Yes, now we can.
So these are the two videos for last Friday and yesterday classes. I'm finalizing the setup of the YouTube channel. I will share this with you during the weekend. Also, there's another announcement will be for the Google Drive, the shared Google Drive, that you can post the bonus question answers. Also, in the folder, you will find a PDF file that will say, for example, for the yesterday class, what are the in-class exercises that you need to answer to get the bonus mark for the class. What else? During next week, also I will share with you, or during the weekend, I will share with you an Excel sheet that groups can add their names. Most probably I will decide it during the week before next Thursday class. I will share with you that if the assignment will be a group assignment, because the class size become huge. Last year it was 90 students and I have 2 TAs. However, this term I have only 1 TA and we have 152 students in the class till the moment. So having these things, I don't want to overwhelm the TA. So for the project, it will be a group minimum of 5 up to 6 in each group. Each term paper will address one topic that we will study in this course, and there is a presentation and some few questions to all a group member. I'll give you all instruction later, and I will assign the just give me a sec, guys. Just my supervisor is calling. I will be posting the topics, and each group at the beginning you start forming your group members. And for the assignment, I believe it will be 2 to 4 students. Yesterday I said 2 to 3, but I'm thinking to have 2 to 4 students per assignment. However, the assignment will be longer. The assignment will be longer, but not that much. That would help the TA to evaluate. As I told, however, all work should be original. All work should be original and not copied and pasted from previous year assignments or other books or other resources in the web, because all assignment will be checked using Turnitin. Is that clear, guys? Hello? Everybody can hear me?
Yes, sir.
Okay, thank you. Now, let's continue from where we stopped yesterday. Just a quick comment in yesterday class. If we wanna, in this slide, slide number 13, in this slide, if we will take it in the current format that x1 included in A, this is not applicable. It should have the subset brackets. If we have the subset brackets, this statement will be true. So the last two statement is the only one which are true, and in the current format in the handout, this will be considered as false, because we said if we give a membership or a set entity or a set member itself, we should use the belong to. We should use the symbol belong to. If we put it as a subset, then this would be true. Without the subset, this is considered as false. Also, another quick comment. What is the cardinality or length of epsilon? Epsilon itself is 0. If it's in a bracket as a subset or as a set, it will be 1. Is that clear, guys? Questions?
I have a question regarding that. Is it because the empty is denoted by an object itself?
Yes.
One be actually
the member
okay.
Epsilon itself or phi itself is 0. If we consider it as a subset or as a set, no, it's length 1 because it has one member.
Yeah, but the member itself is, I guess, non-existent, like non-existent, but doesn't have any value in it.
Yes, so it's 0.
So is in this case going to be 0?
Yes, because if you click here in the link in Wikipedia, so epsilon itself, the length is 0 because we are talking about the member of the set itself. If we talk about a set in a set theory with the brackets, it has a member, so its length will be 1. So we have to differentiate between these 2 points. You know, yesterday class, I'm currently in Jordan. So yesterday class in Jordan timing, it was 12:30 to 1:30 a.m. So I was a bit sleepy, but I clarify in the previous video. Also at the end of the video, one of the students raised this issue who remain in the class. So we clarify this point. But I want everybody to have a clear idea about this thing. Okay, we stopped yesterday here. The string concatenation. So once we are working with the strings and alphabet, any string concatenation will have the first string, then we will contact the other string beside it. For example, if we have the A is a string consists of 0, 0, and we have B which consists of 1, 1. If we say concatenate A and B, it will be 0, 0, 1, 1. If we have A, let's say AB, and B is CD, and we concatenate them, it will be ABCD. Could it be CDAB? Yes, if we ask the concatenation to be a BA here, not AB. So also in our example, if we ask the concatenation to be a BA, then it will be 1, 1, 0, 0. Is that clear, guys?
Sir, I have a question about sigma. So why does
It
it
is not
matter what we
sigma. In
have?
our course, we call it alphabet.
Okay. Sorry. What I mean is, well, I was saying for the array or the string, we have 0, 1. What is
Yeah.
the necessity of that?
Yeah, so here it will tell you that this alphabet consists only of two symbols. No matter how much time I can repeat them, but any string come out of this alpha, it should include only zeros and ones. Can we
So-
put A, the letter A, in this string? So for example, if I put here 00 A capital, is that a valid string from this alpha?
If we have the A inside it, I'd say
If we
so.
have the A here, yes.
Yes.
We don't have the A, it will not be a valid string from this language.
So my question is, does the size of the array dictate the amount of repetition we have on the specific characters, like 0, 0, 1, 1? So if you had 0, 1, 2, would it be 0, 0, 0, 1, 1, 1, and 2, 2, 2? So the size
Yes,
of like
yes,
A,
yes. The repeatants depend on the grammar. How is the grammar of this language? When we come to deterministic and non-deterministic finite automata, so we don't have any string or any language or any programming language, we should have a finite number of members. There is nothing infinity.
no, I understand that, but what I'm trying to
So if we
understand.
have, as you said, 0, 0, 0, 1, 1, 1, 2, 2, 2, 2, if this line under the language grammar, that would be a correct and valid string. If
Okay.
not, no. We will see more example, and all of these things will be clarified in handout 2, 3, and 4.
Okay, right. Thanks, sir.
Yeah, but here, for the time being, if any alphabet sigma consists of 0 and 1s, so nothing, no valid string rather than those who contain 0, 1, 1, or 0 and 1. For the repetition, we will have more rules, and we call it a grammar. We'll have it later. But now we are starting step-by-step manner. Okay, if we say here, we can here, if we put this degree, you will have the repeatance. This might clarify your question. So if we have AB squared, what does that mean? So we have to repeat the phrase in between the brackets in the same order as much time like the power represent. So here we'll have 2, so I will say AB, AB. Is that clear?
Sir, that wasn't the issue I had. My question is for the alphabet we have. So it's 0, 1, which means 2 characters. So the array size is 2. So let A is equal to 0, 0, for example, as we have. Would that be if the alphabet size, the array size were 3, would we have 3 zeros instead of 2 on the A side?
No, no, no. You can have only 1 0 or 1.
No.
So the repetition of the member should be determined by the grammar.
And okay, but because we don't have any grammar rules at the moment.
Let me clarify it for you. For example, the English alphabet. The English alphabet. It has a finite number of characters. So as a set of alphabet, let's consider the lowercase. So we'll have from A to Z, right? But in any word, I can write as much A's, B's, C's, the letters, what are the combination? Is there a restriction to write a word?
There is, well, as long as the word exists, there's no restriction. But if it doesn't exist or doesn't make sense, then I guess those are the bounds.
The same thing we have to, the same thing we have to understand that the computer is doing, or the computational is doing.
No, I understand.
Or the computational device. So doesn't mean that if the set consists of 2 members that I should have each string consist of 2.
I guess I couldn't make myself clear. The only question I have is, so we have let a equals 0, 0, which is 2 numbers.
Yes.
Is it the reason why we have 2? Is it because the string size is 2, or it doesn't matter?
No,
So
no, this is just an example.
Okay, so it's
So
not
we can have only
bound
1
by
0,
anything.
we can have 3 zeros.
Okay, so it's not bound by anything. So that's why I want to make sure.
Yeah,
Okay,
yeah.
I understand.
Okay. Now, if we have as here our example, if we have a square b square, what does that mean? That I will have a b b. Now, what is the answer of a b here? Here a and here b. What will be the answer of the first one?
It will be just 0, 0, 1, 1, 0, 0, 1, 1.
Yes. So we'll take a 0, 0, b 1, 1, then a 0, 0, then b 1, 1. Here, if we square each string of those string that coming from this alphabet, then we'll have to put a b b, which mean 0, 0, 0, 0, 1, 1, 1, 1. So the order, how we put the power, is very important. So a square b square, it is different than ab altogether square. Is that clear, guys? In the string, how, because this will come later, how we concatenate string in the language, and we will check and we will prove if it's regular language or irregular language, it meets certain condition or doesn't meet any condition, and we can prove that the language is regular or irregular in handout 5, I believe. So these orders are important in a string, because if, let's say, we'll write the word thank. Can I put AKTH? No. If I want you to repeat the phrase thank you in any language, can I put thank for 4 times? Can I put thank you? No. Thank you, thank you, thank you, thank you. If I ask you, I put a square above thank, or the string that contain the letters THAK, A and K, then if I put like, consider like A equal thank and B equal you. If I put this one, then it will be thank you. If I put this one, it will be thank you. So it is important for programming languages to use the correct grammar and to write correctly. Now, if you write a command that is wrong in Python, how the interpreter or the compiler of Python will know that it's correct statement or word or line of code or correct line of code, it's wrong. So it's see each one after another, each letter after another. And it will check whether it's in the dictionary, the language dictionary, which means this is a command, or it's an assignment statement, or whatever. Or a string to be printed in the screen only, or to be saved in a file or in a record. So, guys, this course all about the basic concept, how we will deal at the low level with a computational device, and what are the capabilities of this computational device, the starting of computational theory, what do we mean by computation? So can anybody, you took some programming courses, you took C++ at first year, or it's become Java, I believe, now 1036. It's Java right now.
It was C++ for me, sir. I'm not sure.
Yeah,
but
yeah, I know, because
yeah, I'm not sure if they
start
switched.
Java. So some student took Java, some student took C++, whatever, the concept is the same. So when we are saying, if I will ask you, what do we mean by computation? You are studying computer engineering or software engineering or computer science. We have some computer science students. So if anybody come to you, hey guys, you are studying computation, right? Yes. What do we mean by computation? and you want to identify computation to non-specialized person. So how can we let them understand what do we mean by a computation? What example I can give them? What example or examples I can give them to let them understand what all our study about? Can anybody answer, guys?
I think it's like the compiler translating the high level language to the computer language, like zeros and ones.
This is correct, but this is scientific. So if you wanna tell your grandpa what we are studying. So if you
can I
him
give it a
high level
shot?
language and machine learning and 0 and 1, he will not understand, right?
Yeah, I'm guessing, sir, you're asking us to explain it to a person who doesn't know anything about computers in a
Yes.
simplistic way.
Yeah.
I'd say it is, imagine having a washing machine and you're putting stuff inside it. You're putting the cleaning supplies and the chemicals inside it, and you're trying to make it work to get clean clothing. In the same respect, we give to the computer lines of code that it needs to get in order to make sense of it and return us the results, same as clean clothing.
Okay, I will ask another question. It will lead us to answer this thing. Normally, I like simple phrases. So assume that we are in a physical classroom. We have a face-to-face lecture nowadays, and it's become very hot inside the classroom. And I ask one of the students, can you please open the door? What he will do? Can you explain in a form of algorithm what the student, I ask him to open the door, what he will do?
He will respond to it saying yes, stand up, walk towards the door, turn the knob, open the door, and his request is completed.
Okay. If this is, we understand it as a human because we have thinking and a brain that God gave it to us. So as a human, we have the intelligence and we have the thinking skills, but the computer does not have intelligence or thinking skill. What we instruct the computer, he will do. So if we will ask a robot what he will do, he will the first scan his position in the room, find the way how he will direct himself to go to the door, raise the arm, open the door, put it to the way, take back his arm, scan again, and find out like a GPS where to go and to sit back. So what we call this? So the computation, what do we mean by computation? The simplest definition I found ever. It is a step-by-step solution to problem. It's a step-by-step solution to a problem. So we have to instruct the computer all these step-by-step to arrive to our goal. Is that clear? What do we mean by computation? So let's have some example. What kind of a problem that need a computation? Multiplication of two numbers, 2 by 2. This is a type of computation problem. Checking whether a path, assume that we have a graph. So checking where there is a direct path between any two verses in the graph. This is a computation problem. Now, if I ask you to get me a meaning from a word in a dictionary, how we will do? Normally, all of us will open for any random page will open for any random page in the dictionary, and based on the alphabetical order of the word, we will go like left or right, forward or backward in the dictionary till we reach to that word. Then we will get the meaning, right? This is what we normally do, everybody do. So these are step-by-step solution to find the problem. What is our problem? To find the meaning of certain word. So, example of computation, these are three example or three simple example that I can give it to anybody to know what we are studying, what we are doing in programming. What is computation? The word computation mean step-by-step solution to a problem. Example, the multiplication of any two numbers. Finding a word in a dictionary. Checking whether there is a path between two vertices in a graph. So this is more advanced example. But you can say in the navigation, finding if there is any two direct link from one place to another. This is a computational problem. Okay, now we have a computational problem. To perform computation, what do we need?
A set of rules.
Yeah, some of rules, some kind of algorithm. No, but I mean, we need a hardware, some computational devices that will respond to these rules and algorithm and instruction to give us the solution, right? So we need some computational devices. We have a computational problem. We have a computational device. What are the simplest computational device that we ever know, the humanity knows? The simplest.
The computer, but not the mechanical one, the physical one, the original ionic.
No. Even the mechanical one is advanced one.
I don't know the name in English, but the bowls that you would play when you're kids to count
the abacus,
numbers.
you mean the abacus?
Yeah, yes, abacus.
For counting the numbers. Yes, this is the first computer that we see, but we still have simpler computational device.
And
paper. If you wanted to solve a multiplication problem, when we were in JK, SK, or in primary, what do we use? Pen and paper, and we do all the computation and we find the solution, right? So pen and paper is the simplest computational device that we have, or that we ever have. The abacus is a bit advanced, which help us to find the answer quicker. Okay, what else? After the abacus, a higher level, the simple calculator, the small one. This is a computational device. What else? Nowadays, it is in everybody pocket or in front of you. What is it? Your mobile device. Even the older mobile that we start using at the beginning, the mobile in this size, and we have an aerial. It was Motorola and Alcatel. The first generation of mobile devices, it was 1994, 95. We start using them. Also, those mobile has a calculator on them. And nowadays with the smartphone, it's a tablet, which is considered as a computer. The computer itself, even either the mechanical, guys, do you know in the history which was the first computers in our understanding today, how it was saving information and reading information?
It was a group of females in the World War I, commissioned by the United States. That was the first computer, as documented.
Yeah, in terms of hardware, how it's work, we will collect hole punch computers. We'll have certain of paper or cards, and it's punch holes, and we then translate these holes to our understanding, our normal languages. So those were electromechanical computer. Okay, so in this course, what we are going to study, we will study the computational device based on the resources they have from the scratch, which is the automata. Can anybody tell me what automata in terms of English language? Is it a singular or a plural? Automata.
So I don't understand the question.
Okay, the word automata. We will study the finite automata in this course, right? When we are saying automata, is automata is a singular or a plural noun? As a noun.
Plural.
Plural, yes. Thank you.
Almost says singular.
What is the singular of automata?
No?
Sorry?
Automaton.
Automaton, yes. Thank you. So when we are saying automata, it is the plural of the word automaton. Okay, so in this course, we will study computational devices based on their resources that they use. First computational device in this course that we will study, we'll call it the finite automata. What is the finite automata? It is a computational model. It is a computational model which has, I will post like handwriting. I wrote these notes before the class. So normally by next week, I will scan them and upload them in the resources. So if you need to write some notes for yourself, that's okay. But also any handwriting thing, I will write it in my handwriting and scan it and post it in OWL. So what is the finite automata? It is a computational model which has a certain, between brackets, finite amount of memory. This is the simplest computational model, that it has no processing resources, but we have just a memory with a simple instruction and algorithm that doesn't require a processing device or CPU, as you know. More specifically, finite automata has a state and number, has a state and number of states. We have a finite number of states, nothing infinity. Can anybody give me from the C++, from the software construction course, from the data structure, anybody can give me a case of finite number that is not accepted by computational device? Shake your head and think about it, guys. What about an infinite loop? If we have an infinite loop in your program, does it work?
No, because we can't have infinity. It's always
Yeah. So yeah, exactly. Thank you. So your program will hang at certain point and will not continue to the lines. So infinite loop is infinite automata. Can any computer till today that solve a problem with infinite loop? No. So I need you to understand that any computational device, even supercomputers, data centers, anything, has some limitation, some restriction, some problem that could not be solved till today. We will see later in the course, maybe after assignment 3, that we have some problem that couldn't be solved till today. There are some computational and mathematical problems that no solution till today. So I need the computer, the computational model, the computational resources or devices, all has limitation, and it could work or it can work with a limited or certain or finite number of states, symbol, etc. These concepts is very important for us to begin this course. I took almost 2 weeks, but this will make a solid base for everybody when we move on next week. So this would help us a lot. So the finite automata again has a certain number of states which require a certain amount of memory. Clear, guys? So first part of our course, we just need some memory locations.
Sir, it's not exactly related to this lecture, but is it possible for us to have the upcoming lecture notes pre-posted so we can actually read them?
This weekend I'll put week 2 and 3. And
Okay.
I told you I just traveled to Jordan for emergency case. So I will arrange to have a scanner to scan also even the handout. So during this coming week before Thursday class, everything will be
Okay, because as you said, this was a recap. These lectures. That's why I want to read the next lectures, but because we didn't have them, I just want to make sure. But thank you.
Yeah, but still, I believe that we cannot continue the first handout today. But by next class, we can move to handout 2. So you will have handout 2 and 3 always available.
Okay. All right. Thank you, sir.
You are welcome. Clear, guys? Any question? Okay. You still see this screen, right?
Which screen, sir? The formal language one?
Yes.
Yes.
Okay. So in a computation, when we are saying a formal language, over alphabet, what does that mean? A formal language, you can go and read about formal language over an alphabet denoted by the letter L. So when we are saying L in our course, till the end of this course, that means this is a language. Over an alphabet sigma, denoted L is a subset of sigma star, or clean star we call it. It is basically a set of strings. The kind of formal languages we are interested in are ones that can produce by some kind of rule. As one of your colleagues said before, that we need to have some computational model, we need some rules, we need some grammar. What do we mean by grammar? It's a set of rules that will formulate this language, how we can write our string in this language, and it could be computationally applicable. So this is a formal language. So if we have alphabet consists of 0 and 1, what language is 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0? What is that?
Binary?
No, we can give it a name, that a language of strings that end in 0. Some other student will say a language of a string that must contain a 0 in each element of that set or of that string. Because we see 0, 0, 0, 0, 0, 0, but we couldn't see like a string consists of ones, right? Only. So you can call it a language of string that end in 0. This is correct. A set of language that must contain at least 1 0 in each string. That's correct. So when we are saying what language 1 0 1 1 0 1 1 0 1 1 0 1 0 0 1 and 1 0 0, can you give a generic description of this language?
I guess no one else is. Never mind.
Strings that should contain 1.
Yes. Thank you. So a string that at least, here we said at least 0 or end in 0, but here we have something end in 0 and some in 1, so the previous description is not valid, but we can say it's at least contains 1. How does this differ from natural language like English? How is it similar? Can you brainstorm to answer this question?
I think it's different because if you have a natural language, it's gonna have, I mean, probably thousands of rules that could be written down, but also there are exceptions to these rules. So with these languages, like in the binary that we've looked at, if it's a rule, it's a solid rule. You can't have an exception to that, but in English and most natural languages, there are always going to be exceptions.
Amazing. In the computer, we don't have exception. That's correct, 100%. Can you write, for example, a line of code of C++ in a Python program? Unless you integrate both languages, consider it's not integrated. Can we write a code? Do you know the older languages that was used before, like Fortran, Pascal, what else? Smalltalk, the first object-oriented in the world, object-oriented language? Or even, can you write a C# in a C++?
No.
No. So, as your colleague said, for example, even for me, like I'm bilingual, I can speak 2 languages. Sometimes when I speak in my mother tongue, I insert some other language words. And even, for example, if you wanna say about a French perfume, even in English, sometimes you pronounce it in French. So, and it will be acceptable, and the person in front of you or your friends or the people you are talking to will understand what do you mean. But in a computer language, you cannot. As your colleague said, there is a rules with no exceptions.
So can I make a point regarding that?
Yeah.
I mean, I understand, but then again, if we do consider that kind of regulation, if the person, so same thing as the interpreter that we use on Java, like let's say Eclipse, if the other person has no clue of what you're saying, let's say you're trying to talk to him in 2 different languages, and he doesn't know anything about, let's say, in English, but you're trying to talk to him in your mother tongue, it's the same concept as the compiler or, you know, Eclipse, for example, to actually try to understand it. So it's not, sure, there's no hard-coded rules, but in the name of coding itself, the rules are done by us. You can create exceptions regarding that. I mean, before the 8 bits being, you know, the normalized, you could have had 13, you know, bits, then none of the code would make sense. It depends on the way it's implemented. So,
yes,
and we use binary to make the system work. So I don't think they're that different in the essence of it. Sure, we have more complex nature of it, but at the end of the day, when we're coding, we're using English language as the majority for our sake, but at the end of the day, we're using machine language to actually interpret it whichever way we want. So it depends on the compiler. If you have a compiler that isn't a kernel, for example, which then it's nothing different.
Yep, that's amazing. That's amazing. Thank you. So, as your colleague said, for example, assume that we have a person who speaks Spanish and I could not understand the Spanish. So in order to communicate, we need an interpreter. The same thing, this is the similarity between as a human and as natural languages and how the computer. So if you write like a Java, the computer will not understand Java. It needs a compiler or interpreter to convert this to the machine language, which is 0 and 1, then the processor will understand it and process it. So one of the similarities that even high-level languages and natural languages, if you are talking or communicating with somebody else who does not understand this language, we need a compiler, and we call it in programming languages a compiler or interpreter. Who can tell me what is the difference between compiler and interpreter in the programming languages?
I can give it a shot.
Yep.
As far as I remember, it's been a while, but an interpreter doesn't require the operating system, but the compiler is dependent on the operating system. And that is why in the past, people who used to run Mac software and try to use the same code in XP wouldn't be able to use it even though they were using the same thing.
Mhm.
So in the essence, one of them interprets the data depending on the software, or for the interpreter, it interprets the data and creates a basic language that could be used for every different compiler. So for example, Java, like the Visual Studio is a compiler, Java itself is a compiler like Eclipse, but no, interpreter, sorry. But compilers would be, I guess, like hard to explain, but in the essence, the main difference is one of them is dependent on the operating software it runs, and the other one is dependent on itself, and it would have to have its own system to run. It cannot function without it. So yeah, command prompt lines, essentially. So command line will be the compiler. Command line prompts, the one that we can use from the Windows shell, would be a compiler, and the Eclipse program that we download would be the interpreter. Without the Eclipse, we cannot code it, and without the compiler being on the Windows system, the system will not understand the code.
Just to let you know that any compiler or interpreter or any software will deal with the operating system to run, because the operating system is the system that will schedule the task and send it to the processor and manage the input and the output and the memory location and schedule the task and give it the priority. So my question was, in a programming or in a computation or a theory of computation, the difference between compiler and interpreter, that the compiler will compile the whole program, then give you all the errors at once, like C++. However, the interpreter, when you write the code and you move to the next line, if your line has an error, it will give you immediately. So the interpreter is compiling or interpret the code line by line. The compiler will read the whole program and give you the errors all at once. Is that clear? Both will translate from programming languages, whatever it's intermediate language or high-level language, to machine learning. To machine language. But the difference between compiler and the interpreter, again, that I write a program in C++, I compile it, it will give me all the errors at once. The interpreter will let you move to the next line if there is an error in the top line. Clear, guys?
Sir, so my question is, isn't for the interpreter, there is no actual object code generated? Like no, like if the code doesn't, like compared to the compiler, the whole system runs, then we have the error and like the backend feed that we have to clear if they're using C. But if you have the interpreter, it would only run one line of code. Then there's no object code created if the line of code is not.
No. What I mean in the theory of computation later on in the lessons, we will start like finding if this string is valid, is invalid, acceptable by the machine, not accepted by the machine. The interpreter check the grammar and the rules line by line when you write your program. The compiler will let you complete your program. Once you compile it, it will check it all together at once. At the end result, both do a translation from high-level language to machine language.
Mhm.
As a result, they are the same, but some languages like Visual Basic before or .NET, they use the interpreter. Some other languages, they use a compiler. Just, I want to let you to differentiate between this in the concept of theory of computation. How we check the string, is it correct or not correct? Because what you write, each line of code is considered as a string.
So it's not a direct question, but where would the data will be stored for the interpreter? Would it be in the heap, or how would it be allocated? Since if it's
Now it depends on the operating system. If you're using Linux, different than Unix, the old one.
Yeah.
Different than the Windows, either it's 32 or 64.
I meant for
How is the
not
internal scheduler? How is the movement between, because you know, there is a course, if you are computer science student, you will have a course called system programming. So you will start from assembler, loader, linker, then in the other level will be interpreter or compiler. Okay, and the operating system, because the operating system consists of different.
Yeah, it's called 3342. It's elective for engineers and computer science students, I believe. So.
Yeah, so I'm not sure if all students took it, and it's, I believe it's a 4th year course. So once you go there, and even the assembler itself, it depends on the operating system. Some operating system, they have 1 pass assembler. Some of them, they have 2 pass assemblers, you know, and the linker itself, which link the machine code with the processor and operating system and organize all the things and make them. Did you get, guys, the operating system course? I don't want to go more deep in this, but in the operating system course, you know how the scheduler will make the critical section in the memory and the semaphores.
Mm-hmm.
So each operating system deal differently, and you know there are a lot of scheduling algorithm. It depends on the processor. Nowadays with our technologies, like a Core i7 9th generation has 6 cores. This was before in 1995 a mainframe computer in a university. So each operating system has its own, the concept is the same, but the way it's implemented and how it's managed, the task and the processes, it's different.
I guess.
But we are talking about the upper level.
Yeah.
How we design the programming languages and how we let these computational resources. We're talking about from one like narrow corner, which is computation.
Mm-hmm.
So we'll not move to the hardware side. You know, there is a computer architecture, the operating system, the system programming course, and the assembly class. And I don't know if in Western they offer the assembly course, programming course, the assembly language.
Yeah, it's 2209, I believe.
Yeah.
It's assembly.
So all these courses are connected together, but here we took from high-level programming languages vision.
Okay.
But in the low level, what is happening? It's not our call in this course.
Okay. Yeah,
but
that's why
if you
it
have
wasn't
any
a
question,
direct question.
I'm more than happy to answer. I love these topics.
Yeah, that's why I said it wasn't directly connected. So
yeah.
Because yeah. Okay. Thank you.
Thank you. So I think your colleagues might mainly answer this question. You might expect computational to be posed in a kind of ask a question, get an answer fashion. For example, if you have this equation, y equal x squared, and it say let x equal 3, find y, then the computation you'll do 3 by 3, then it will have 9. So this is an example of computation problem, but we do it in our mind quick because we have thinking and intelligence capabilities. But for the machine, we need to instruct the machine how to do that. That's how computation occurs in effect. But for this course, and indeed for the purpose of studying computation, we are going to pose the question of computation as decision problem in our parabola example that like asking yes or no. Is the 0.39 on the curve yes or no? So mainly this course, for the simplicity, it's designed by the university not to go in deep details. However, I'm happy to answer in deep details, to answer any question you have in deep details. But for the sake of course and the material covered, you will find mainly or mostly it is about yes or no. Okay, guys, I'll give you a 5-minute break to drink water or do something. Then we'll back at 9:35. Hello, everybody. Again, we're back to our course and our class. Okay. So, informally, the computation is modeled as answer to yes, no question. To yes, no question. Everybody can hear me?
Yes, Professor, I can hear you.
Okay, thank you. Okay, guys, just I received some comments from the student in chat that some student, if you have a question that not related direct to the class or to our material, I'm more than happy to answer, but during the office hour. So some students, they have like some complaint that it is an early morning class in Canada, so they would like to move on in the curriculum. I'm more than happy to answer any question, but please, if you have some question or some clarification in your mind, I'm more than happy, or at the end of the class. Okay, now to continue. More formally, computation means given the description of some language L and it has an input string of S, so we will compute to have the answer. What do we mean by yes or no? That is this string belong to this language? Is it accepted by this language? Like if parenthesis A greater or equal to B, close the parenthesis. Some languages will write the word then you write the decision. Some languages you put a comma. How the syntax of that language. So is the string I wrote in my code accepted by that language or not? So does L accept S or it does not accept? If it's not accept, that will raise an error in my program and could not be computed. If it's accepted, then a computation process will happen. So what are these rules that we put? What we are checking is this is the rule of the language. Is this string accepted, or the line of command or the line of code is accepted or not? Some language, like before Pascal, it was a language used till 2000. Programming languages, for example, the assignment statement A colon equal A plus B. If I put A equal A plus B, that means I'm checking is A equal A plus B. If I put the colon, this is an assignment statement. Other languages, you will put in C++ equal to ask if it's equal as a logical expression with answer yes or no or true or false. And the assignment statement in C, A equal B, A plus B. So if I'm writing in Pascal, if I write A equal A plus B, this is a condition. If I write equal in Pascal, it will not be an accepted string. So no computation will take place.
Sir, I just have a question regarding that statement. Isn't it insufficient to say it is only to decide whether S belongs to L? Since even that doesn't really mean the computation will actually occur. It just means it verifies that it is accepted. It doesn't mean to actually function. Like you could have a unregistered.
Yeah, here at this point, we check if it's accepted. If it's processed correctly or incorrectly, this is a different story. Here in the theory of computation, we check is what I wrote is accepted by the language and fulfill the rules, and the program will be run. I'm not saying the output is correct or not. Here we are checking, does what I wrote in my program fulfill the requirement and rules of that language? Yes or no?
Okay. Can I ask one more question regarding that? Is that okay?
Yeah.
Do we consider faults as well as failures in that regards when it comes to computation as well? Since having a, string X, let's say, but we didn't initialize the value for it, would that, that wouldn't be a...
You go further advanced.
Okay.
This course we still in handout 1, and it will come step by step. Okay, so don't go beyond what we are talking about. I understand that you have the encouragement and you like to have as much information as you want, but all your question will be answered maybe in handout 2 or 3 or 4. So I don't want some other student to be confused. If you have more question, you can sit to the end of the class and you ask whatever you want. Just write down your question and I'm more than happy to answer. Okay, now we will start with deterministic finite automata. Okay, let me share I will have one example to clarify before starting with the finite automata. Can you see my paint?
Yes, sir.
Yes. Okay. Assume one of the simplest example in our life, which is the electrical switch. The electrical switch. The electrical switch either would be on or off. On or off. And we said if the finite automata is consist of a set of states, of a finite number of states, right? So when from now and forward, this is the symbol of a state, a circle. It's a circle. So we have either on or next class I will use my pen pad. So it has two states, either on or off. What will change the state of the electrical switch between on and off? What will change?
Like
the
if you interact with it?
Between on and off.
If you toggle the switch?
If we push the switch. So if it is on and we push the switch, it will lead to off. And if it was off, and we switch, we push the switch, it will lead to on. The switch will be in the state of on. So here we have in this graph or in this automator two states, on and off, on and off. And what is the action that would be taken to translate you from one state to another?
Sorry, sir. What do you mean by what action? Just
Which
switching?
is the push action. Which is the push action will transit you between states. So in a finite automator, we have a finite number of states that I will move from one state to another if there is an action. If there is an action taken. In electrical switch example, what is the action need to be taken? Push the switch. If it's on, it will become off. It's off, it will become on. So, is that clear? So we will represent the state. We will represent the states circle, and we can write on them what are they, or later on we'll start calling them Q0, Q1, Q2, each state. And in between the state, there is an arrows represent the direction of the flow of actions. And what are the action? Either push, or if I input letter A, or if I input an alphabet, or if I input 1 or 0, whatever. So you will become more familiar with finite state diagram. So I just wanna give a previous example. We'll have a lot more example forward. So when we define a deterministic finite automata, and we will start using DFA. For finite automata, we'll use FA. It is a deterministic finite automaton, is a 5-tuple. It's not a set, it's a tuple. So the order is important. It has Q, which is set of states. Q capital is set of states. Alphabet, the transition function, and the Q naught, which is the initial state or the starting state, and F, which is belong to the set of state, which is the accepting state or the final state. So which is the final state. And normally we make it in a double circle inside. We will see. We will see later on. For example, this question. The Q, which is the set of state, consists of two states, Q0 and the Q1. If we have an alphabet consists of 0 and 1. In a Q0, if we have 0, it will back to the same state. It's like a loop. If we have 1, it will go to Q1. If we have more zeros, it will stay in Q1. If we enter 1 as the input in the string is 1, we will back to Q0. Here we call the transition function row. If we have a Q0 and it's 0, we'll stay in Q0. If we have a Q0 and we have 1, we will move to Q1. In a Q1, if we have 0, we will stay in Q1, and in a Q, this is a Q1, huh? This is a Q1, this is a typo. And in a Q1, if we have 1, we will back to Q0. So initial state, we normally write start, so we begin from here. So normally we write start, then arrow. This is the initial state. So we will normally start with the Q0. These are the accepting state. And this is the final state. So once we determine what is the accepting state, which means the last state I will stop at, it is a Q1, and we make it in a double circle. What language does this accept? 0, 1, 0, 1, 1, 1. So what language does this accept?
Binary.
Yes. And any binary number. Any binary number. I could start with 1, I could start with 0. How many zeros and ones? I can do whatever I want. And I can stop by 1 or 0. How is this model different from, say, a Melee machine? You can read about Melee machine in the website. So a finite state which output is defined. So here I can write if 0, 0, 0 or 1, 1 or 0, 0 or 1. So I can move anyhow in between. So this is the Melee machine. For now, we will focus only in yes, no problem. I'll not go in deep details in these figures. With example, you will understand what is required. We'll have a lot of example in this. For now, we will focus only on yes, no problems, hard enough as it is. So at the way that we have, that is an automaton either accept given string or does not accept it. Accept or not, yes or no. The notion of output will become clearer when we talk about Turing machine. So some question will be answered in handout 8 or 9. Turing machine have a tape, which means a memory. This machine doesn't have a memory. Now, when we talk about DFA, we don't have memory, which is the simplest kind of computational model that can leave behind the result. Okay, guys. Questions? Next class, we will again, I will post it right now, handout 2 and 3. I'll put it in OWL so you can read, and we'll go more in example. We'll have a lot of example using the pen and paper. So we'll not move till you understand what do we mean by those. Is there any other question, guys? If
So
no, if you
continue the class, or are we done?
No, we're done. So
Okay.
those who doesn't have a question, you can leave. Those who has a question, you can stay. And have a nice weekend, guys, and see you next Thursday.
I had a question about the previous slide, by the way.
Which one?
Previous slide.
This one?
Okay, yeah, well, that one. So, wait, no, the one before this one, the other, yeah, this one. So when you said what languages does this accept, it wouldn't accept just 0, right? If you have just 0, you would be stuck on Q0.
No,
So you would never get to Q.
Yeah, it will accept any binary digit number.
But if you say
number.
just 0, it won't accept it.
0, 1, for example, if I have 0, does it accept 0 itself?
No.
No. 0, 1, and stop. It is
That
accepted.
accepts.
0, 1, 1, then I should
It's
have
not accepted.
another one.
So 0, 1, 1 alone is not accepted.
No, 0, 1,
1, 1.
1 is not accepted, then I should have 1.
All right.
So 0, 1, 1, 1 is accepted.
All right.
So if I have 0, 0, 1, 1, is this an accepted string?
Yes.
Are you sure?
0, 0, 1?
1.
Oh, 0, 0, 1, 1. No, that's not accepted.
Yes. But 0, 1 is accepted.
All right.
0, 1, 0, 0, 0 is accepted.
Yeah.
So
Sir,
There's a
with more
condition here.
example, you will understand more, because we'll have more example we'll have a clearer example. This is just an introductory one.
So you can finish at Q0. Is that what you're saying?
We can finish at 2-0. Why not? If I have 0-1-0-0, we can. Because if I have 0, I will stay in Q1, which is the final state, and accept state.
He said Q0, the state.
I mean, like the final state can be Q0.
So yeah,
Yeah.
so they're asking the first node.
If I have 0-1-0-0, this is 0. I'm still in Q naught. 1, I'm at Q1. 0-0, I'm still at Q1, which is accept state.
My question is, can you not finish the sequence at and end up
No,
at
no.
Q0 as your final state?
What is our title?
Finite.
So we should have a limited number.
No, he meant, can you end at Q0? Like, can you finish at Q0? It's not allowed to finish at Q0, or you have to finish at
No.
Q1.
If a Q naught has a double circle, which means that Q1 and Q naught both are accepted state, then we can stop at Q1. But if I have only one circle at Q naught, I start from Q naught, but I cannot stop at it. For example, if I put a start at Q1, then I can, if I put a start at the Q1 and the Q1 is a final state, then I will start with the Q1. I can move between Q2, Q0 and the Q1, but I have to back to Q1. So the one with double circle is the final state. So I should stop at final state.
So I have a question. I have a question regarding this one. So, I'm guessing we are using the same kind of structure as we would with sequence diagrams. So, is it possible for us to have multiple final nodes? Because let's say this is a comprehensive system, and we have multiple if statements. Essentially, this is if statements, and at the end we would have multiple final nodes.
Okay,
Is that correct?
Miti. Do we talk about if statement?
No, but
There is, we will have later on in the example branching, and we'll talk about all of those.
right. That's so. Isn't it possible for us to have two different, both Q0 and Q1 to be final?
Yes.
So in that retrospect, for this one, it wouldn't work, because if we were to do 0 all the time, it would just be infinite loop. But if they were both possibilities, then it could be just 0.
We will explain when we have two final state. When we will have multiple final state, we will have, this is in the future example. Don't jump, Miti. It seems to me that you are running in a marathon, huh?
Also, I don't know how to respond, but yeah.
No,
like
cool down, take it step by step. Miti, your background is computer science, right?
yes. Well, in engineering, computer science.
My background is computer science, so I know, because in computer science we go in a deep details. But with software engineering, with this course, because even software engineer has nothing to do with compiler. They study the testing, the verification. They are practical more than to go in deep details inside the language and understand everything. So this course, as a software, if in computer science, I will give it different way, in more deep details.
No, I understand this.
For software engineering, it's designed at this level. I'm happy to answer all your question, but you make some confusion between the student if we go in these deep details, so they will get confused.
No, so I'm asking just because my internship with IBM is happening, so I just want to make sure I can understand everything. And this is one of the...
I'm more than happy. You can come in every Wednesday from 4 to 5 in my office hour and ask as much as you want. And if that time is not enough, I can assign another hour, no problem.
Okay, thank you, sir.
Yeah, you are welcome. Okay, guys, any more questions?
Yeah, I actually wanted to ask about something like 2 slides before, about accepting states. Oh, yeah, just now. Like F is equal to Q1.
What?
Go one more slide to the right or down. Yeah. Here. So
Yeah.
the reason why F is equal to Q1 is only because Q1 is the last state, or it's the only state that you can end off on.
This will be decided by this tuple. When I saying a Q, okay, when I saying a Q, and for example, this tuple, if you write it in a question, I will give you Q, and in between it has Q naught and the Q1, so that means you have only two states. And alpha, which consists of 0 and 1, I have to clarify that for you in the tuple. Then I'll put the row, the transition function, which is this one, how you will move between states, so you are able to draw this graph. And also I have to let you know where is the starting point to put the arrow start, that we start from here. And I have to give you the final state, F, which is the accepting state, we call it. State or states, it could be both. So this will be determined by the question or the language that this language rules here. So we can stop here or here or here. For example, you will see some example that we have 10 states. So I can stop at 3 of them or 4 of them, as much as I want, or as determined by the language rule. So once I have a deterministic finite automata, I have to specify to you these 5 members of this tuple. Based on these 5, you can draw the diagram. You cannot draw it from your mind.
Okay, so in this case, the reason why Q0 is not included in like
this is the rule of this language.
the
I
set
receive
of
this
accepting
tuple.
states.
I receive this tuple saying that the final state is a Q1. Okay, I have to do it. So it's not my choice.
Okay.
So
no. As in, like, I just wanted to make sure.
When it will be when it will be your choice. When it will be your choice. If I give you a question in the exam, I saying, if we have a language that has the following rules, could you design a DFA that fulfill this language and this rule? Then you will decide where to stop based on the condition I gave to you, that what this language will do. For example, that if I said to you, design a DFA that will accept a language that start with 1 and end with 0 or end with 00. So here you have to think how many state I need. What is the alphabet? I told you 0 and 1. What is the transition? How many, which is the final state? This at that time you will do. And I'll give you an example how we will do that next class. Is that clear?
But at least in this case, in this case only, the one that you gave us, we can only end at Q1. That's not a typo.
Yeah, it's predefined Q1 by the example. By the example, it's predefined.
Okay.
Yeah. So is that clear, guys? Any other question?
Professor, I was just wondering if you were going to post the Google Drive and the PDF things today, and if that was due next week, just to clarify.
Yeah, during this weekend. Today is a Friday, so tomorrow and after tomorrow, everything will be posted and announced to you guys. Even the video, the recording, everything.
Okay, great. And we have until next week to submit the worksheet to the Google Drive.
Yeah, the bonus worksheet, yes.
Okay, thank you.
Till the end of Thursday class.
Also, sir, where can we get the worksheet?
It will be in the Google Drive sheet, and I will post the link in the announcement in OWL.
Okay, so we'll have it. Okay. Gotcha.
It is any class. It is any class question that I asked yesterday and today. So I will mention that in slide number X, question 1 and 2, for example. because we have some question in the slides, so that some of them will be included in the worksheet. You have to answer only those questions.
Okay.
Any other question, guys, or shall I stop the video and the sharing? Okay, have a nice weekend. See you next week, guys. Wait during the weekend to have all resources available, and the any class questions also will be posted in Google Drive, and you can paste in the same folder. And all you will have a clear instruction for everything. Have a nice weekend and bye-bye.
Have a good day,
Bye,
sir.
sir.
You too.
Well, good night for you, but yes.
Good night.